Question 1. Write down 168 as a product of its prime factors. Well, 168, that's 2 times 84, and 84 is 2 times 42, which is 2 times 21, which is 3 times 7. So what we can write is 2 times 2 times 2 times 3 times 7, or we could write 2 cubed times 3 times 7. Either or, that's fine. Part B, find the highest common factor of 168 and 180. Well, luckily we already have 2 times 2 times 2 times 3 times 7 from the previous part. And let's do the same. Let's do the prime factor decomposition of 180. Well, that's 18 times 10, which is 3 times 6 times 2 times 5. And 6 is just 2 times 3 again. So we've got 2 times 2 times 3 times 3. I crossed them out so I know I've got them all. Times 5. Now let's see what they have in common. Well, that's all they have in common. And what we need to look at is, what does 168 want that it hasn't got from the prime factors of this one? Well, it needs to get 3 times 5, so it needs to get 15. So 168 times 15 would be the answer. Alternatively, you can look at the 180 and say which factors does it want to get its hands on. The 2 and the 7 under multiplication is 14. So 180 times 14 should be exactly the same. So let's try. So 168 times 15, that is 2,520, and 180 times 14, that's 2,520. So that's that part done. Question 2. We've got to work out who drove at the greater average speed in this particular question. And we've got 2 people, Eric and Geraldine, and they both set off at 2 p.m. One drives on Route 1, and that takes 48 minutes to go 36.4 miles. So that's going to be 36.4 miles, and then let's have it in miles per hour. So we've got 48 minutes, so that's going to be 48 60ths of an hour. We can do that on the calculator later. And then for Geraldine, we've got 1 hour and 25 minutes, and the route is 65.2 miles. Excuse me. So that's 85 minutes, that's an hour and 25, so that's 85 60ths of an hour. And then we can work that out in miles per hour. So let's have a look at Eric's. That's 36.4. 36.4 divided by, and then bracket, don't forget, or you can do that separately if you want, but I'm going to do it all in one go. So 48 divided by 60, close bracket, and I get 45.5 miles per hour. And then for Geraldine, it's 65.2 divided by, open bracket, 85 divided by 60, close bracket. On the calculator, that's going to be 46.0 miles per hour. There was a 2 after the 0, but we did it I'm doing it to 1 decimal place here. So we can see that Geraldine has the greater average speed. Question 3. There was an accurate scale drawing of a school playground. And if I can move this, I can show you. That's what we had. This is very hard to do on a computer, so what I did is I printed out the exam paper, did the full question, and I can just explain what I did. So the first thing was the scale. 1 centimetre is 2 metres. and Nassim is going to put a seat in the playground. The seat has to be less than 9 meters from C. So what I did was I put my sharp point of my compass here, and you can see that I've drawn a circle of radius. Well, it'll be 4.5, wouldn't it? Because it's 1 centimetre is 2 metres. So that's the first thing that I did. The second thing is closer to BC than AB. Well, I put my sharp point here, and what I did was I kept my compass at 4.5 centimetres, and I did a little dash here, and then swung it around and did the same here. Then I moved my sharp point, I kept the distance exactly the same, and I did another dash here, moved the sharp point to here, crossed them over, and you can see I've joined a perpendicular bisector up here. Okay, so that's cut the angle in half, which means I can then differentiate between being closer to AB or closer to BC, and it wants it closer to BC. And then the last thing that I did was and you can interpret this in different ways. I wasn't told that it was a rectangle, you see, so I got a bit nervy and I thought, well, I'm just going to draw a circle of radius 2 centimetres because it's 4 metres from AB. I did one there and I did one here, and then I can put my ruler against this and just draw a line straight along, and that would be 2 centimetres here, wouldn't it? Because it's 4 metres and 2 metres is 1 centimetre. But having spoken to a few of my colleagues, some of them have said, and I'm kind of in agreement, that you can just measure off 2 centimetres. I just thought it might be a bit dangerous because we don't know that that's the right angle here and here. But either way, if you draw the circles, it'll be fine. If you just mark off 2 centimetres, the mark scheme seems to allow that. So we've now got to shade in where we're less than 9 metres from C. So that's going to be anywhere in here. Then we've got to be closer to BC than AB, so that is anywhere here, and then more than 4 metres from AB, which is in this part here. So what I'll do is I'll just outline in black the region that would be allowed. That's not very good, a bit better than that. And we'd basically have any of this area here is where the seat could be placed in the playground. Question 4. There are only red counters, blue and green counters in a bag. The number of red counters to blue to green is in the ratio 1 to 3 to 7. So there's red, blue and green. So how many red ones are there? What would be the probability of red? Well, altogether you've got 1 and 3 is 4 and 7 is 11 parts, and 1 out of those 11 is red, 3 out of those 11 is blue, and 7 out of 11 is green. So I'm just going to put those as fractions. We don't have to decimalize these. Now it says, Jamie takes at random a counter from the bag and records the colour of the counter. He then puts the counter back. He does this a number of times. He records the total number of blue counters, and that is 68 blue. We've got to work out an estimate for the total number of times Jamie takes the counter from the bag. But I think we can work that out reasonably quickly, because we know that 3 out of 11 times is blue, and that represents 68 counters that are taken. So we have to try and make 3 elevenths into 11 elevenths, because then we'll get the whole amount, won't we? Because they all have to add up to 1. So if 3 elevenths is 68, then 3 is going to be 68 times 11, because we just times both sides by 11 in proportion. And then if we divide both sides by 3, then our final answer will be this on the calculator, which we can do. So if I do 68 times 11 and then divide by 3, I will get 249.3 recurring. So I'm going to just round it down to 249 times, because it's only an estimate, don't forget, and that will be my answer. Question 5. Mariam is trying to expand and simplify n minus 2 all squared, so n minus 2 multiplied by itself. Here is her working, so this first line seems okay. Let's have a look what we would have if we multiplied those out. Plus 4. So we've definitely got a minus times a minus here, haven't we? So that's going to give plus 4. Well, she has a minus 4 here, so that's definitely one mistake that you could pull out of everything. This seems okay, as does this. So everything's okay apart from the negative 4. So you can write your own explanation there. The next part says Josh is trying to factorize x squared minus 6x plus 8. And his reasoning is, because 4 times 2 equals 8 and 4 plus 2 is 6, then x squared minus 6x plus 8 is x plus 4 times x plus 2. Well, he's nearly correct here, but I think that the situation is that he should be looking for two factors that sum to negative 6, not 6. So almost there, but not quite. So this bit looked fine, and only if he had to put maybe this in here, because they were both negative, and then he would have had negative 4 and negative 2 would give negative 6, and then you would have put this in like so. So let's have a look if we did do x minus 4 multiplied by x minus 2. Yes, we'd have the x squared. We'd definitely have the positive 8, which is good. And then we've got the minus 4x and the minus 2x, that gives the minus 6x. So it's kind of like saying factors of a are 4 and 2. So I don't mind this too much. And 4 times 2 does give 8. But the way in which you use the 4 and the 2 is that you're going to have to start with negative 4 and then take 2 more away. So you're really being using negative 4 and negative 2. So let's have a look at the last part. Well, let's get rid of this bit here. Shona has to draw the line with equation y equals 3x plus 2. Here is her line. Explain why Shona's line cannot be correct. Well, it's got a nice upward gradient, so that's looking okay. But it's this part here, isn't it? The intercept cannot be positive because it's below 0. So if it was maybe 3x minus 2, then that could be feasible. Okay, so what should we put for our explanation here? And what I've put is the y-intercept should be negative in her actual equation here. Question 6. The diagram shows a quadrilateral JKLM, and we've got to work out the size of angle KLM. So that's this angle KLM. So let's label that. Now, I think the quickest way of doing that is to know a little bit more information about that right angle triangle, KLM. And to do that, we can find this length here, and we can use Pythagoras, because it's another right angle triangle. So we can say KM squared is 4.5 squared plus 7 squared, and you can use your calculator here. So that is going to be 69.25. So Km is going to be the square root of 69.25. And I'm just going to leave that as it is for now. instead of decimalising the whole thing. Now, what I shall do is now look at the other triangle, KLM, and I'll say to myself, okay, it's a right angled triangle again. I've got the opposite here, and I've got something opposite the right angle, which is the hypotenuse. So I've got opposite and hypotenuse, so I can use sine, and I'll call this theta. So sine theta, the angle KLM, is going to be opposite, which is root 69.25 divided by 15. So the angle is going to be arc sine, or sine minus 1, of root 69.25 over 15. So let's put that in the calculator. So we've got arc sine, and I'm going to do bracket 69.25 to the power, and I'm going to put 0.5 because that's the power half, which is the square root sign, and then divide by 15, and then close the bracket. What you can do if you're worried is just do each part on its own separately. So work that out first, call it A and S, and then do sine to the minus 1 of A and S. That's another quick way of doing it. And what I get on my calculator is theta is going to be 33.695 37249. It wants it to 3 significant figures, so the 9 will change the 6 to a 7, so theta is going to be 33.7 degrees, and that's 3 to 3 significant figures. So not too bad a question there. Question 7. Liquid A has a density of 1.42 grams per centimetre cube. 7 centimetre cubes of liquid A is mixed with 125 centimetre cubes of liquid B to make liquid C. And it tells you at the end that liquid C has a density of 1.05 grams per centimetre cube. We've got to find the density of liquid B. Well, let's not make it too complicated. Let's just look at A, B, and C separately. A has 1.42 grams per centimetre cube, but we're told that 7 of them are added of liquid A. So that's the mass, because we've got 1.42 grams for every centimetre cube of that liquid. And as we had 7 of them, that's the total amount of grams. Okay, so we can put that in grams. For B, well, what have we got? We've got 125 grams of liquid, but we don't know what the density is, okay? And that's what we want to find out. Because if you think about it, density is mass per volume. So if we want the mass, we just rearrange this equation here by timesing both sides by V, and we get density times volume is mass. And as it's the mass we're trying to work out each time here, because we had the volume of liquid for B, what's left, x, must be the density. So for C, we have the density is given, and that is 1.05 grams per centimetre cube of liquid. But the total amount of liquid for C is the 7 and the 125 from the 2 liquids A and B. So that's 132. So that's going to be the mass in grams of liquid C. So we know that A and B made C, so we can form an equation. So we've got 7 times 1.42, which is 9.94, plus 125x equals 1.05, doing that on my calculator, times 132, which is 138.6. So if I rearrange this equation, so I'm going to do 138.6, take away the 9.94, which is 128.66, and I'm now going to divide both sides by 125. So I get 1.02928. I'm going to give them to 2 decimal places because they're in the question, if you can see here. Oh, and it also says so just as well. And let's have a look. So I'm going to say 1.03 grams per centimetre cube, and I'm just going to write 2 dp there. Question 8. Kira used her calculator to work out the value of a number x. She wrote down the first 2 digits of the answer on her calculator. She wrote down 7.3. Well, what's the error interval? Well, she definitely saw the digit 7.3, so I guess we could have started off with that number. But how high could the number have been? Well, I guess the highest it could have been is lots of 9s after the 3, filling up the calculator display. So that's not quite 7.4, is it? So it could be equal to 7.3, but not as high as 7.4, or she would have seen the digit 4. So that would be the error interval that I would give for that question. Question 9. Francesco carried out a survey about the ages of people in his office, and there's a table below showing the cumulative frequency and the age, A, in years. On the grid I've already drawn the cumulative frequency curve, so I've just plotted the end points here versus the cumulative frequency for each one to create my coordinates. I've plotted all the coordinates and then joined them up smoothly, making sure that generally when I draw the curve I go underneath the arc to start with, and then I can just turn my page and then do this arc here. So I'm always doing it so the pen is underneath the arc. It's hard to do without rotating this page. On other videos I go into a bit more detail. So get your cumulative frequency curve really nice and smooth. And then it says use your graph to find an estimate for the median age. Well, as there were 70 people in the office, I went to the halfway mark, 35. I read along. You'll do this with a ruler in your exam. And I read down to 43, and the mark scheme happened to say 43 as the answer. Francesco then says more than 60% of the people in the office are between 35 and 55 years old. Use your graph to determine if Francesco is correct. Well, I looked at 35, I read along and got 16. And then I looked at 55 and then read along and got 63. And the difference between 16 and 63, that's a total of 47. And that's out of 70 people altogether. So I did 47 out of 70, and that gave me 67.1% to 1 decimal place. Now that is more than 60% of the people, so Francesco is correct. One thing to note is that the mark scheme did allow for straight line segments. So if we did have a straight line segment, I don't know if it would have changed too much. It might have made it a bit narrower actually. It might have made this come up to around 18. So, and this might have come down just a little bit, so maybe like 62. So 62 minus 18, that would be, so I should know that in my head, 44 I think. Yeah, 44. And then 44 out of 70. That's if you did it a straight line segment. So 44 divided by 70, that would be 63%. Okay, that's to 2 significant figures I gave there. So depending on whether you did it as a smooth curve or as line segments, you would either get 67% or 63%. Question 10. In a sale, the price of a TV is reduced by 25%. So let's say the TV, let's represent the price of the TV as X. If it's reduced by 25%, then we're only going to have 75% of it left. A week later, the price of the TV is reduced by 15% more. So let's just think that's how much it was reduced to start with, that's how much of it was left, and then it's reduced by 15% again. So we're only going to have 85% of the initial amount left. It then says the price of the TV is now £293.25. What was the price of the TV before the sale? i.e., let's find this value here. Well, to find that value, all we need to do is divide both sides by 0.75 times 0.85. And so we're left with x, and all we've got to do is plug into the calculator, and I'm going to be very careful here. I'm going to put a bracket around this bottom part here, and I'll explain why. So we do the denominator first, £293.25. So 293.25 divided by, and now brackets, because I want to divide by the whole lot of the bottom part here. So 0.75 times 0.85, close the brackets, and I get £460. An alternative would be that you could work backwards, so you could take the £293.25, divide it by 0.85, i.e. You'd have 85% of it left, so if you divide by 0.85 instead of timesing, then you're going to get, let's put that in the calculator, £293.25 divided by 0.85, well, that gives us £345, and then work up to the beginning by dividing that by 0.75. So then you can do 345 divided by 0.75 as opposed to what we did here, which was times by 0.75. So let's divide that by 0.75 on the calculator, and we get £460 again. So I think as long as you show your workings out, you're just going by what the question tells you. It gives you lots of clues, and you use those clues to solve. That's all you have to do. Question 11. We want to expand and simplify these three brackets that are under multiplication. Now multiplication is commutative, which means it doesn't matter which order it's done in. So we can multiply two of the brackets and then the last one. It doesn't matter which two we start with. So let's just go by this one and this one first. So let's do x plus 2 times x minus 4, and then we're going to finally times it by x plus 8. So you can use a grid if you wish. So there's x plus 2, x minus 4. We're going to multiply them out. So that's x squared, 2x, minus 4x, and then minus 8. And that gives us x squared minus 2x minus 8. And then we're going to multiply that by the bracket we didn't use to start with, which is x plus 8. So again, x squared minus 2x minus 8 multiplied by x plus 8. So we've got x cubed minus 2x squared minus 8x plus 8x squared minus 16x minus 64. Then collect the terms. X cubed, 8 minus 2, that's plus 6x squared, minus 24x minus 64. So give it a try. Maybe try doing x plus 2 times x plus 8 first, and then times that by x minus 4. There's plenty of ways of doing that question. Question 12. The diagram shows a metal rod AB, and it's resting inside a cylindrical tin. It says the tin is on a horizontal table. AC is the diameter of the base of the tin. B is on the top edge, that's important. And BC is vertical. Okay, so we've got the radius of the base of the tin is 5 centimetres. So 5 centimetres this way as well. And we're given the volume. Well, the volume of the tin is going to be the area of the base, which is pi r squared, times the height, which is BC. So the radius we're given, so that's 5 squared, that's 25 pi times the height, and the volume is given as 1178. So that means we can find the height by dividing both sides by 25 pi. So let's do that first. So we've got to make sure that when we use our calculator, that you just put a bracket around this bottom part here. To be honest, I'm not quite sure why I did brackets around that like that. So put a bracket around here and that will help you find h. So on the calculator, 1178 divided by brackets 25 pi, close bracket. And I get h here is 14.99876184, and that's in centimetres. So we've got to find the angle between the rod and the base of the tin. So we want this angle here. So we're lucky enough to know what the height is. So we've got opposite, we've got the adjacent. So we've got tan of theta is going to be h, which is the answer in my calculator already, and you've got an ANS button on your calculator probably, divided by the adjacent, which is 10. So theta, the angle, is going to be arctan or inverse tan of ANS over 10. And don't forget, if you haven't got an ANS button, it's just this number here. So I'm going to write on my calculator shift tan of ANS divided by 10, close brackets, and that's going to be on my calculator 56.30774953. We want it to the nearest degree, so this 3 will not have any effect here, so theta will be 56 degrees, and that's to the nearest degree. Question 13. For any 3 consecutive whole numbers, well, let's just choose n, n plus 1, n plus 2. Prove algebraically that the largest number and the smallest number are factors of the number that is 1 less than the square of the middle number. So the square of the middle number take away 1 gives us this number here. And we've got to show that n and n plus 2 are factors of this number here. Well, I think the first thing that springs to mind is that this can be written as n plus 1 all squared minus 1 squared, which is a difference of 2 squares, isn't it? Remember a squared minus b squared? Well, a squared minus b squared gives a plus b times a minus b. So this here should be written as, well, can be written as n plus 1 times n plus 1 minus 1. And that just gives us n plus 2 times n, or n lots of n plus 2. And we can now see that we've proven what we needed to prove. Prove algebraically that the largest number and the smallest number are factors. Well, there you go. N is the smallest and n plus 2 is the largest, and they're both factors of 1 less than n plus 1 all squared, which is the middle number. Okay, so that's my way of doing it. You may have a different way of doing it, and that's really cool if you have. Anyway, good luck with these types of questions, because I think these are quite difficult. Question 14. We've got to prove algebraically that the recurring decimal 0.457 recurring can be written as 151 330ths. Well, let's start off by calling x the decimal. So there we go. Let's experiment with just timesing by 10 first. Let's times by 10 again. And then by 10 again. Now, one thing I can notice here is that if I want to obliterate the recurring part here and here, they match up. So if I do 1000x minus 10x, that's going to be the same as 457.57 recurring minus 4.57 recurring. Maybe it's better if I look at it this way. Well, you can see here that if I do that subtraction, then these parts cancel out, and I'm just left with 453. And it's easy to work out what 1000x minus 10x is. That's 990x. So although this is a calculator paper, I strongly advise, of course, checking it, because the calculator will probably cancel it into its lowest terms for you, but I probably think it's better to show the working. So you could probably see that 3 would go into both, because 3 goes into 45 and 3 goes into 3, obviously. 3's into 45, that's going to be 15, and then 3's into 3 is 1. And 3's into 99, that's 33, but it's 10 times as much. The 3's cancel, and you're left with the required result, 151 330ths. Question 15. On the grid below, we've got to shade the region defined by the following inequalities. Well, we want where x is always less than 4. So if we draw a dotted line here to represent x is 4, we want everything less than it. So we can just shade that all in blue, like so. The next one, let's do this one. Let's say y is a third of x. Well, we know when x is 0, y will be 0, so it would go through here. And we also know, let's just say x is a multiple of 3, a nice one, say 6. When x is 6, y would be 2. So the straight line, and I'll try and do this for you properly. And there we have that. So y is x over 3 would like that. We want it to be always greater than. So we can just give this a good shading like so. A bit more up here. And then finally, we want 2x plus y is 6. If we can draw that line, then we can look at the inequality later. Let's just rearrange that. Well, let's just say we want to look at y equals minus 2x plus 6. So when x is 0, y would be 6. And when y is 0, we would have, by adding 2x to both sides, we'd have 2x is 6, so x would be 3. So when y is 0, x is 3. So we can now draw this line. I'll give this a good go. Of course, you'll do this better in the exam than I will. And we want it to be, now be very careful, we want it to be greater than, so greater than minus 2x plus 6. So we want it to be above the line here. Now, all we have to do is look at where red, green and blue all intersect. So I don't know whether you can see that here. All of those colours intersect there. So our region would be clearly in here. So just so you can see, and it's how you shade in the exam, you can do dotted lines or little dots or something so you don't get confused, because it's hard to get felt tips out in an exam, I understand that. So there we go, that's our region as required just there. Question 16. There is a large number of cubes in a bag. Jason wants to work out an estimate for the number of cubes in this bag. So he takes at random 10 cubes from the bag and he puts a mark on each of those 10 cubes. Right, so he marked 10 cubes out of the total number of cubes. So this fraction here represents the proportion of marked cubes out of the entire population. Jason shakes the bag and then takes at random 20 of the cubes. So he creates another population, it's like a second population of 20 cubes. And 3 of those are marked. So the fraction 3/20 represents the proportion of marked cubes again. Now, putting a mark on a cube doesn't or shouldn't affect its chance of being taken from the bag. The probability of picking a cube from the bag should be the same for each cube that you pick. So we can say that the proportions should remain identical at each capture. So we can say 10 out of n is the same as 3 out of 20. And we can use some algebra to help us here. So what we can do is, and it's up to you what you're more comfortable with, one option is you can invert both sides, i.e. to the power -1. So you can have n over 10 equals 20 over 3. And then you can times both sides by 10. And the answer will be 200 divided by 3. And that is, and you can use your calculator, that is 66.6 recurring. So you could say 67 cubes in total, because that's what we wanted to find here. I guess another way is you can say 10 out of n is the same as 3 out of 20. If you can get these two top numbers to match, so what would you have to times 3 by here to make it 10? Well, you'd have to times it by 3.3 recurring, or 3 1/3. So you'd have to do the same to the top and the bottom to make it equivalent. So if you times this by 3 1/3, you'd have to times this number by 3 1/3. And then you'd have 10 over n is equal to, well, 3 times 3 1/3 is 10 out of, well, 20 times 3 1/3. You can do that on your calculator. That will be 66.6 recurring. So you can see here, the denominator here must match because they're equivalent fractions, and then you can round it to the nearest whole number again. I guess one last way, just because you're going to probably face one of these questions in the exam for sure, is if you had 10 out of n is in the same proportion as 3 out of 20, you could times both sides by n first, and so you'd have 10 equals 3n over 20, and then times both sides by 20, so that would give you 200 equals 3n, and then divide both sides by 3, so you'd have 200 over 3 equals n, and again round that to the nearest whole number. 67 cubes is our estimate. Question 17. We've got a recursive formula here, so we can find values. Given a starting situation, we can find successive values. And we're given that the quantity of radioactive metal is P subscript n and the start of year n. At the start of the following year, the quantity is given. At the start of 2016, there were 30 grams of the metal. Okay, so the first thing to do would be to say that when n is 1. That will be our starting situation. Then we've got P of 1 is 30. So we look along to our formula here, and we can say, well, we let n equal 1 for the first year. So that would be P subscript 2 would be 0.87 times however many grams there were in the first year, which we've deduced is 30. Because it tells us that, okay? Now, what will be the quantity of metal at the start of 2019? Well, if that was 2016, then n is 2 will be 2017, n is 3, 2018, so we want to go all the way up to n is 4. So we know that P2 must be 0.87 times 30, which I'm going to do on my calculator. So 30 times 0.87, and that is 26.1. So going back to my formula here, if n now becomes 2, then we've got P subscript 3 will be 0.87 times what we just found, 26.1. So times that by 0.87, and I get 22.707. So what I can deduce is we're just timesing by 0.87 successively. So P4 subscript 4 will just be 22.707 times 0.87. So we get 19.75509. So to the nearest gram it will be 20 grams, and I'll just write here nearest gram. Question 18. Here is a sketch of the curve y equals sine of x plus a in degrees plus b, and it says given that a is between 0 and 360, which is important, find the value of a and b such that the graph will then look like this, which is given here. Well, the first thing I can notice is that the sine graph, which I've drawn here for you, is peaks at 1 and troughs at -1. Okay, so it's minimum -1 and it's maximum at 1. But can you see here that it's all underneath the x-axis? So what I did was I put the value of b to be -1 because this transformation just dragged everything downwards. So that's the first thing that I did. I set b to be -1, so you can see the comparison there. Then what I did was I thought to myself, well, how could I get the red curve, which I had here, to look like this one? And I couldn't choose a to be negative because it told me I have to have it between 0 and 360. So I set it to 90. Now, if I have a transformation x plus 90, what that will do is it will translate everything 90 degrees parallel to the x-axis. So that's what I wanted to do, and that's exactly what happened. So you can see here, I know it's rather small, but you can see here if I make it go 90 degrees this way, then I'll get the desired result, and you can see the correlation between these two graphs here is perfect. So I've got my -2, 180, just as I've got here. I've got my 360, 0, just like so, and I've got this intercept here at 0, 0. So that's this question. I think that's quite a difficult question, but just try and think, can you translate it parallel to the y-axis first, moving it up and down, and then can you do it left and right parallel to the x-axis? Desmos is a very good graphing package, which is what I've used to show you here. I fully recommend putting in sine x, putting in the question, and then you can do these things called sliders. So you can change the values that you want, and then you can move them with your finger, or you can press play and pause, and they'll move automatically for you. So have a go at that, and I think that will help you with these questions. So let's finish off with the answers, and that is A is 90 and B is -1. Question 19. The diagram shows triangle ABC, and we're given the vector AB, AC, and we're told that BE is 3 times AC. It says D is the point on BC such that BD to DC is in the ratio to 3 to 1. So it's kind of like saying that this part from BD is worth 3 parts and this is worth 1 part. So altogether B to C is 4 parts. So we've got to keep that in mind. We've got to prove that ADE is a straight line. So we've got to prove that that's a straight line. So I would suggest that we've got to show that AD is some multiple of AE, or vice versa. AE is some multiple of AD. We could also show that AD is some multiple of DE. And if they are, that means they'd be parallel. Well, not necessarily parallel, they'd have to be the same straight line, because if they weren't, and this is this case I'm talking here, if AD wasn't in the same direction exactly in terms of the same gradient, then it would be at a different angle, i.e. not the same straight line. But I think we'll just see how the problem works out and we'll see which one we're going to use here. Well, the first thing to think about is, what about BC? Well, to go from B to C, that's the journey minus 3A plus 2B, or just 2B minus 3A. Now, we know therefore that BD would be 3 out of the 4 parts of 2B minus 3A. And we know that DC would be 1/4 of that, because we've already looked at that ratio, haven't we? Now, what's the next thing that we can look at? Well, I think the next thing we can do is just put these in here. And I'm just going to write in DC as well. And then I think what I'm going to do very quickly is I'm going to look at AD separately. So I'm going to say, right, AD, to go from A to D is the same as going 2B minus CD, which is minus 1/4 2B minus 3A. And then what I can do is I can look at the whole of A to E here, and I can say that A to E is the same as going 3A, and then, right, BE, have we got BE? Yes, we have, thank goodness. It's 3 lots of AC, so it's going to be 6B. So 3A plus 6B. So what we can do is from there, we can just take 3 out as a scalar. So that's A plus 2B. And that's quite important, because what we can do is we can look at this carefully. We can try and now justify from here whether they're multiples of each other and see which one of these we're going to look at. And it looks as though we're going to look at the one relating AD and AE somehow. So let's look at this one. We're going to have 2B minus 2/4, I'm going to leave it as 2/4 B, plus 3/4 A. Now 2 is 8/4, minus 2/4 is 6/4 B, plus 3/4 A. And the reason I did that is because I can take the 3/4 out, and then I'd have 2b plus just a. So that's AD. Now, what have I got here? Well, you can see this one here is a plus 2b, and you can see this one here is a plus 2b. You could just rewrite this one more time underneath and have the a first, then 2b afterwards. And can you see that one is 3 lots of a plus 2b, and the other one is 3/4 of the same gradient. So when you're looking at these, and you can see AE is the whole of the vector, including going through D, because A to D is a multiple of the same gradient, they'd have to be on the same straight line. I think there are other ways of doing this, and I'll just write down for you some of the other vectors that you can have in this question. Let's just get rid of all of this. And I think one of them was, so we have AD is 3/4 of 2b plus a. We have DE is 9/4 of 2b plus a. Or we have AE is 3 lots of 2b plus a. Okay, so you may have done it a slightly different way, but they're the outcomes that you can use to help show that it's the same straight line. Question 20. It says there are 9 counters in a bag, so let's just draw these. And it says 3 of the counters, there's an even number. And on the other 6 counters, they're odd. 3 counters are going to be taken at random from the bag. The numbers on the counters will be added together to give the total. Find the probability that the total is an odd number. So our first choice could either be even or odd. Our second choice, let's just go to change the colour here. Our second choice, well, if the first one is even, the second one can be even or odd, even or odd. And our third choice, again, even, odd, even, odd, even, odd, even, odd. Now, not everyone needs to draw a probability tree like so, but I find them quite helpful. First thing to do is look at the outcomes. So even and an even and an even, that's going to be even. The next one is 2 evens make an even, and an odd, well, that will make it odd. Then an even, an odd, and an even. Well, the 2 evens, that makes it even, and the odd makes it odd, just like the one before. The next branch has 2 odds and an even, so 2 odds make an even, and an even is an even outcome. 2 evens and an odd is odd. 2 odds and an even is even. It is quite confusing actually, but I hope you're bearing with me. Then 2 odds make an even, and an even is even. And then 3 odds, well, 2 odds make an even, but you've got another odd to add on, so that'll make it odd. So thank goodness we've got these. So we've got this one, and so we've got 4 altogether. So now it's quite easy. We can just do the sums now using the calculator at the end. So I'm not going to write all the numbers in the tree, but basically to get to the first one, we had an even, which was 3 and 9, times another one, which is 2 and 8, because one's been chosen already. And then the last odd, well, that'll be 6 and 7. So the denominator, I think, 9 8s is 72 times 7, I believe that's 504, just check. Yep. and then we've got 36 here. And then the next one is going to be 3 and 9 times the odd, which is 6 and 8, times the even, which is 2 and 7. So that looks like another 36 in 504. And then an odd, which is 6 and 9, times 3 and 8, times 2 and 7. So that's another 36 in 504. And the last one is odd, so we've got a 6 in 9, times a 5 in 8, times a 4 and 7, which is slightly different because that's 30 times 4 is 120 over 504. So the final denominator is 504, and let's add these together. That's 72, 108, 228 out of 504, and that should be absolutely fine. You don't have to cancel that down. Question 21. We have a function of x, which is the cubic, x cubed, and we have another function of x, g of x, which is a straight line, 4x minus 1. We have to find f of g of 2. So we work from the inside, so we start with g of 2 first. So that means wherever we see an x in the function g, we put 2 in its place. So we have 4 times 2 minus 1, which is 8 minus 1, which is 7. And then we have to do f of 7. So in its place here, we would just write 7. So basically what we end up with is 7 cubed. And on the calculator, I think it's 243, but I could be wrong. 7 to the power 3, 343 of course, yeah. So 343. So a calculator needed there for me because I've forgotten what 7 cubed was. Now, the next part is, it says that h of x is f of g of x. Find an expression for the inverse of h of x. Well, g of x we know is 4x minus 1. So we've basically got to work out what f of 4x minus 1 is, because don't forget, we work from the inside to the out. So I'll just change the colour of this so you can see. So wherever we see an x in the function f of x, we just replace it with 4x minus 1. So that will be 4x minus 1 all cubed. So how do we find the inverse? Well, I'm sure you've been taught this by your teacher. So what you do is, you let, for example, y equal 4x minus 1 cubed, and hopefully you've been taught that when you graph a function and its inverse, they always are perfectly reflected in the line y equals x. So I'll come back to that in a moment. So basically all we have to do is try and undo the function so we get x on its own. So we'll cube root both sides. We'll add 1 to both sides. And we will divide both sides by 4. But coming back to this, if it's always reflected in the line y equals x, if we had a function, say here, and we wanted to find its inverse, it would look like this. It would be a complete reflection in the line y equals x. So if we let y become x, i.e. we swap these around, y becomes x, then we end up with the function x to the power of a third, because don't forget y becomes x, plus 1 divided by 4. Now that's a quick way of doing this, and that's without loads of explanation as to why that's the case, but ask your teacher or a colleague or a friend who you think knows this a bit better than you why the line y equals x is really important, and that should undo about how to relate h of x to the inverse. Question 22. Quite a difficult question, I think. There's going to be quite a few steps involved just by looking at it. We're given the formula for a circle. Now, one that's centered at the origin is x squared plus y squared is r squared, where r is the radius. So we know that r squared is going to be 261, so r is the square root of 261. Let's just get that out of the way first. We're also given that at point A, we're given the coordinate p minus 15. And we've got to find the equation of the tangent to A, i.e. the equation of the line that goes through A, i.e. the tangent here, okay? So we've got to be very careful how we approach this question. So the first thing I'm going to do is I'm going to zoom in on the actual circle, and I'm going to put in the distance here, which I know, which is root 261, the radius. Another clue is I know that the y part is minus 15, so down by 15. So I also know that I can create a right-angled triangle with this distance here being 15. I can then use Pythagoras to find this distance here, p, i.e. this number here. And if I do Pythagoras, I'll have 15 squared plus p squared is the square root of 261 all squared. So that's 225 plus p squared is just 261. So p squared, and you can use your calculator, it's 36. So p is plus or minus 6, but in this case we're going along 6 here. So p is 6. Now, does that help us? Well, I think it really unfolds from here, because all we have to do now is try and think if we can work out the gradient of the line that goes through here, we can then work out the gradient of this line, because when we have two gradients that are perpendicular, if we multiply them out, we'll always get negative 1. So why don't we call this L and L1, so just to distinguish between them. So what is the gradient of L? Well, one way of looking at it is if we zoom in here, and I'll choose a different colour, we know that if we went along here by 6 units, we had to go down by 15 units. So if we went along 1, i.e. let's divide this number by 6 to make it 1, and then if we scale down the whole triangle, we've got to do the same to this length as well, then that means that if we've effectively gone along 1 unit, we've gone down by this number here, which is 15.6. Now, don't forget it's going to be a negative gradient because it's going downhill, so you just got to put the sign in here so you don't forget. So we know the gradient of the line L, so I can write that down here. So we know the gradient, and I'll do a subscript here, L, is minus 15.6, and we can cancel that down because 15 is 3 times 5, 6 is 3 times 2. These cancel, so we get the gradient of the line L is minus 5 over 2. But we also know it goes through the point 6, negative 15, doesn't it? Because we found the value of p at that coordinate A. So we can just use the straight line formula, put the numbers in, and we'll be good to go, I think. So let's change the colour here. So we know that y equals mx plus c. Don't forget we want the equation of the tangent here, L1. So be careful, this gradient will not be minus 5 over 2. It will be the reciprocal, but the negative of it. So it will be 2/5. We know we can make y this number here because we know it goes through that point, 6, negative 15, and we can say x is 6. That then leaves us to find the value of c, and then we can use that value of c to give our final answer for our formula for the straight line. So let's try putting the numbers in. So we'll have negative 15 is 2/5 of 6 plus c. So negative 15 will be 12/5 plus c, times everything through by 5. Negative 75 equals 12 plus 5c. So that means 5c will be negative 87. So c will be minus 87 over 5. So what will the equation of the line L1 turn out to be? Well, it'll be just be y equals the gradient of it, which don't forget is 2/5, x plus the intercept, which is minus 87/5. So we can neaten that up to be 2/5 x minus 87/5. And as a decimal, and you can use your calculator, that'll be 0.4x minus 17.4. Now, they're quite difficult numbers. This is the answer on the mark scheme. I think if I was doing this question in the exam, I'd begin to sweat a little bit, and I'll be trying it probably 2 or 3 times, I think, to try and see that I do actually concur with that answer. So really practice these questions, because that was a difficult one.